The first two equations that we need to understand is the geometric series and the arithmetic series. So what are these series? The first series is the arithmetic series, and why we need a closed form formula for the series. So this is our series. Now if you want to find, let's say, summation from 0 up to 100, then you need to expand the summation by writing when I is 0, then 0 plus 1 plus 2 up to 100. So that means you have to know all the numbers from 0 up to 100, add them together, you get an answer. Is there an easy way to find the answer without going to the previous values? Yes, which is this equation. So this equation says that you can find the answer. N is 100. So simply substitute. It would be 100 multiplied by 101. You divide it over 2 and you will get the answer directly. So how we can find this equation from the sequence? This is for your information. I'm just providing that thing for you to understand how we got this equation. Let us label S as 1. And by the way, you can start from 0 and you can start from 1. It will not change the addition because 0 added with any number, it will not change the result. So I will assume that we have 1 plus 2 plus 3 up to n. And remember, we will go up to n minus 1 and then we will go up to n. Now write the same S but in reverse order. So start from n, then go to the next one, which is n minus 1, go to the next one, which is n minus 2, and keep doing this until you reach 2 plus 1. Now add them together. So when you add them together, you are going to get 2s. And probably I should write it explicitly. Add s plus s, and it's going to be equal to 2s. So when you add them, we will combine these two together. We will combine these two together. We will combine these two together. And at the end, we will combine these two together and we will combine these two together. So we will take them into pairs. So the first pair will be n plus 1. And this is coming from here. Now the second pair will be also n plus 1. The third pair is also n plus 1. And if you keep continuing this, then you will have n plus 1 as the last one. So how many n plus 1 do we have? Here in total we have, this is n times. So s plus s is equal to 2s, and here on the other side we will have n multiplied by n plus 1. So what is s is equal to? It is n times n plus 1 divided by 2, and this is the one that we want to find. For the other sequence, first we need to expand it so that we can understand it, how it looks like. So S is equal to, when I is 0, see, when I is 0, then R raised to power 0 is 1. Now when I is 1, R raised to power 1 is 1, is R, sorry. And then the next one will be r squared, the next one will be r to the power 3. And as you notice, it goes up to n minus 1. So the last one will be n, r, n minus 2, r, n minus 1. This is the last one. Now multiply s by r. So multiply s by r. So we will have shifting to the number. So 1 multiplied by r is r. R multiplied by r is r square multiplied by r is r cube, and it continues. And remember that for the last one will be Rn, because Rn minus 1 multiplied by n by r, it will be Rn. Now subtract s minus rs. So combine these two, subtract these two, this is equal to 0. Subtract these two, it will be equal to 0. Subtract these two, it's equal to 0. And again, you will subtract these two, it will be equal to 0. So this one is already subtracted from the previous value in here. So what is the equation that we are going to get? First, we will put 1 as an answer. Then we have 0 for this part, and we have 0 all the way until the last one is 0. And for the last one, if you notice here, there is no corresponding value for Rn on top, so the answer will be equal to minus Rn. So S minus Rs is equal to 1 minus R raised to power n. Now you arrange, multiply both sides by negative number, so we will have Rs minus S equal to Rn minus 1. So therefore S is equal to Rn, and maybe I should put one take S as common, so it will be R minus 1 is equal to Rn minus 1. So S is equal to Rn minus 1 over R minus 1, and remember R should not be equal to 1. And this is the equation that we are going to use for the geometric sequence. A question is raised here, what if R is equal to 1? If R is equal to 1, then you have to go back to the original definition here and put 1. So when R is 1, so anything raised to power, so 1 raised to power anything is 1. So it means that you are adding 1 n times, so the answer is 1. So if R, I will write here, if R is equal to 1, then S is equal to n. Otherwise, if R is not equal to 1, then this is the equation we have for the geometric sequence. Now, what if the indices of these summations are not the same? Okay, for example, suppose we ask the following question. So here is an example. Find the summation for I equal 1 up to n minus 1 for I, and summation that I starts from 3 and it goes up to n, let's say also minus 1 for I. So as you notice that this one starts from 1, but this one does not start from 1. So what was the summation? We had the arithmetic summation I equal 1 up to n, and this was the equation. So how to find a closed form equation for these two? If you have a summation like the first example, if it starts from 1, then it is easy to find the closed form summation. And notice this goes up to n and this goes up to n minus 1. So what you have to do, so I will just copy it, and then we will start from here, paste. So this is going to be equal now. I will put on one side and then I will erase it. Summation for I equal up to ni is equal to n times n plus 1 over 2. So both starts with 1. So all what you have to do now for this equation, remove n and put n minus 1 anywhere, both sides. So instead of n, put n minus 1. Instead of n, put n minus 1. So the result that you will get when you replace n by n minus 1, it will be n minus 1. And here when you put n minus 1 plus 1, it will be equal to n. So multiply it by n and divide it by 2. So it is a very simple substitution as long as the start value are the same. Now for the second one, which it does not start from 1, it starts from 3, okay? And if it does not start from 1, it starts from 3, then we need to do an adjustment, okay? So we need to do an adjustment so that we can make it start from 1 instead of starting from 3. Now, the number of terms that we are going to have here should both be the same. So this one starts from 3, it terminates at n minus 1. The number of terms that we are going to add should be exactly the same if we start from 1 up to, and we have to see what is the value here. Let's go for the initial value first. Here, this one, the first value, when I is equal to 3, the first value is a 3. So how can I get a 3 when I is equal to 1? It is very simple calculation. It will be I plus 2. So when you substitute 1 in here, you will get a 3, and this is the first value you will get here. Now for the last value, how to find it? Remember that the last value in this summation is n minus 1, and here you have I plus 2. So when I have I plus 2 is equal to the last value n minus 1, from here we can say that I is equal, so you take 2 to the other side, and you will have n minus 3. So the value for here will be n minus 3. So substitute this one in here. Then, since this summation starts from 1, then we can say that the summation of I equal 1 up to n minus 3 of I plus 2, we distribute, and this will be equal to summation I equal 1 up to n minus 3i plus summation I goes 1 up to n minus 3 of 2. So this is equal to, for this summation, the new one, just remove in this equation, see? Now in this equation, remove n and replace it by n minus 3. So this will be equal to n minus 3. And when you put here n minus 3 plus 1, it will be n minus 2. So you will multiply it by n minus 2 divided by 2. Now for the second term, here this is a constant. So you can take it outside. So the question, how many numbers do we have from 1 up to n minus 3? By subtracting both of them, n minus 3 minus 1, and then we add 1, the answer will be equal to n minus 3. So that means we are going to multiply 2 by n minus 3. Do the simplification and you will have a closed form equation for this summation. Similarly, for the geometric sequence, let's consider the following example too. So, as an example, find the following two summations. So find the first summation, I goes from 0 up to n for 3 raised to power I, and the second one, summation, summation does not start from 0, but it starts from 1 up to n, 3 of I. So here we can put any number, but I will put just n and see how we can find the closed form equation for these two geometric sequences. By writing the geometric sequence from 0, remember this is the one we have Ri. Now R is equal to 3, so it is summation 0 up to n minus 1, 3 raised to power I, which is equal to 3 raised to power n minus 1 over 3 minus 1, which is 2. Maybe I should write it explicitly from the rule. So here we have 3 minus 1. This is from here, the geometric sequence, which is this one. See, I starts from 0, it goes up to n minus 1. So don't look for n minus 1, just look for the start. So what we will have here, okay, for the first summation I equal to 0 up to n, 3i. Now since it starts from 0, see the relationship between this number and this number. I will write it in a color so that it will be clear to you. Now see how we are jumping from here to here. We are in fact adding 1. Do the same for any other one. So if you write, for example, if you want to find from n, then you add 1. So your answer will be equal to 3 raised to power n plus 1 minus 1 over 3 minus 1. So just simply put whatever the value here plus 1 over n. And this is the only n we have on the right-hand side equation. Now for the other one, make the adjustment so that it starts from 0, because our original geometric sequence starts from 0. I will surround our original geometric sequence. So to link the answers for the new ones. And now this one, the new one, starts from 0. I need to make the adjustment, because if I is equal to 1 on the left-hand side, the first value for 3 will be 3 raised to power 1. So if I put just only 3 raised to power I, then the first value will be 1, not 0. So how to make it start from 1? So we add 1. So here now if I is 0, then we will have 3 raised to power 1, which both will start from the same number. Now for the last number in the sequence, like what we have done for the arithmetic sequence, plus 1 is equal to n, yn, because see, this is the one we want to find, it goes up to n. If I want to make I plus 3 reaches n, then solve this equation, so I is equal to n minus 1. Now substitute. So we have summation that I goes from 0 up to n minus 1, 3 raised to power I plus 1. And this is equal to, now this is a 3, this one is a 3 multiplied with 3 raised to power I. And you can take a 3 outside the summation. And this will be equal to 3 times summation I goes from 0 up to n minus 1 for 3i. Now here apply the geometric sequence here. So if you want to see, starts from 0. So all what you have to do, just add n minus 1. And you will have on the right hand side a 3 multiplied by 3 raised to power n minus 1 over 3 minus 1, and this will give us the answer. The other rules of summation that we need to review is, first is if we have a constant k multiplied by a function in terms of I, and not necessarily that this is a constant, maybe an equation, but it has a variable not equal to I, then you can take it outside. Now if you have two equations in terms of I, so you can distribute the summation over them. So if you have a plus and minus, you can distribute the summation. But if you have a multiplication of two functions, then you cannot distribute the two summations over these two functions. For the closed form of summation that goes to I, it's equal to n multiplied by n plus 1 over 2. Now the closed form equation for I squared, because we will use this equation for some examples later, it's equal to n multiplied by n plus 1 times 2n plus 1 over 6. Now if you want to remember this equation, then n multiplied by n plus 1, this is coming from summation of I. And 2n plus 1 is an odd number. See how odd numbers are represented? 2n plus 1 divided by 6. Now for I cube, it is simply what is inside is the summation for I goes up to 1 up to n. And this, if you remember, it's n plus 1 over 2. So for a cube, It is the summation that goes up to I raised to power 2. By this time, we have finished today's lesson. In the next lecture or lesson, we will show you how to find solutions to recurrence relations.